Okay, here we have section 5.8. These are applications, meaning that they are story problems. And I know how excited some of you get about story problems, so here we go. My kind of hint here is that we're going to think multiplication. Basically, all of these story problems are going to get set up using some sort of multiplication to make it work. Okay, so that's really kind of what you want to have in the back of your mind. So I have my first example on the board. We'll do a couple more after this one, but let's get started with this one. So it says the product of two consecutive odd integers is 35. Find the integers. Okay, so I'm going to refer us back all the way to chapter 2 when we did story problems before. And when we did story problems, we talked about how consecutive integers or consecutive even integers or consecutive odd integers worked. So feel free to go back and check that out in chapter 2. But basically, if I call my first number x, the second one has to be 2 more than that because they're both odd integers. So it could be 9, and then the next odd integer would be 11. That's 2 more. And so that's why we use the x plus 2 here. We know that the word product means multiply. So you'll notice I wrote out x, the first one, times x plus 2, the second one, and it has to equal the 35 that we were given. So I did a couple of things in one step here. I multiplied out the parentheses, so ignore the 35 for just a second. X times x is x squared. X times 2 gives me the 2x. And because I have limited space, I wrote this all in one step. I also subtracted the 35 to get the 0 that we know we need to solve by factoring. Okay, so I kind of crammed that in there because I have limited space. But that's what we have. X squared plus 2x minus 35 now is equal to 0. This factors. The pair that we want is positive 7 and negative 5. It'll make it work, I promise. Go ahead and check me, but it works. 7 times negative 5 is negative 35. 7 plus negative 5 is 2. So this one, because it just had the x squared out front, factors to be x plus 7 times x minus 5. And this is a 0, I promise. There we go. Looks a little more, man, got some bad zeros. There we go. So then I split it up. X plus 7 could be 0, which gives me negative 7. X minus 5 could be 0, and that gives me positive 5. Now, the more observant among you would notice at this point that negative 7 and positive 5 are not consecutive odd integers. They're not in a row, right? One's on one side of 0, one's on the other side of 0. They are not in a row. Well, here's the thing. This is going to happen a lot when we do story problems like this. We're actually going to get 2 possible answers here. Remember, our x is just our first number. So if x is negative 7, then x plus 2 would be negative 5. Negative 7 plus 2 is negative 5. And there is one solution. But we also had x is equal to 5. So we can put an or here. And if x is 5, right, my other possibility, then x plus 2 would be positive 7, and there's a second solution. And notice that these all both work. Negative 7 and negative 5 are consecutive odd integers. They multiply together to be a positive 35, as do the 5 and the 7. So we have 2 potential solutions here. By the way, if you only give me the 5 and the 7, which is the common one, that way people make mistake here, and they just are like, hey, it's 5 times 7. I won't give you full credit, so I really need both of them. So anyway, there's our first example. Don't worry, I've got more. All right, time for our second example. The length of a rectangle is 5 more than its width. If its area is 36 square feet, find the dimensions. Okay, so I drew a rectangle because I tend to find that to be at least a little bit useful. All right, so here's what I want to do. I have the information about the length that I don't have for the width, right? I know that the length is 5 more than the width. So I called the width W. Okay, I gave it the variable. You can use X if you want. I really don't care what letter you use, but we have to pick a letter for something. And so I'm picking it for W because I know that the length is 5 more than the width. So notice I'm not using another letter. I'm using W again, but I know that the length is 5 more, so I have W plus 5. All right. So then I say, okay, well, how do you find an area? Area is usually length times, actually it's always for a rectangle, it's always length times width. So I take my W times W plus 5, and together they have to equal the 36 that we know the area is. So I expand the parentheses, W times W is W squared, W times 5 is 5W, and then I need equals 36. I need 0, right? This is the first rule that we learned back in the last section. To solve these things, you have to have 0. So I subtracted the 36 from both sides, which gets me 0. Then it factors. Okay, the pair I need here is positive 9 and negative 4 to make it work. So it factors to be W plus 9 times W minus 4. I split it up. W plus 9, that gives me W equals negative 9. W minus 4, that gives me positive 4. But here's the thing. This is a rectangle. Right there it is. There's my rectangle. Anybody ever see a rectangle with a negative side? I just don't think so. Okay, we don't do that. So the negative 9 here is just an extra solution that comes around because of how we have to go about solving this. So we're not going to keep the negative 9 in this case. Last case where we had the consecutive integers, we can have negatives there. But here with a rectangle, we don't want that. So we're going to throw the negative 9 away. So my width is 4, and my length is 5 more than that, which gives me 9. And so there's my solution for this rectangle. This is a 4 by 9 rectangle. All right, there we go. One more example. All right, here we have my last example. I actually ran out of room, so we'll have to clear the board one more time to finish it. So do me a favor. I'm going to read this problem here in just a minute. Make sure you get it written down because you're going to need it because I'm going to have to get rid of it for the to finish the problem. All right, so this one is going to make use of what's called the Pythagorean theorem. The Pythagorean theorem deals with right triangles, so they have to have this 90-degree angle in them. And what it says is that a squared plus b squared is equal to c squared. You're like, okay, what the heck does that mean? Well, a and b are what we call legs, so they're these short sides that are attached to that right angle. And c is called the hypotenuse, and that's always the long side that is across the triangle from the right angle. So right there. So here's my problem. Here's what I want to work with. It says the hypotenuse of a right triangle is 5 inches, and the legs are consecutive integers. Find the lengths of the two legs. So I know I'm going to be using my Pythagorean theorem because it tells me basically when it says it is a right triangle. That is just like a flashing neon sign saying use the Pythagorean theorem. So we know the hypotenuse. The hypotenuse is 5 inches. That's c. C is always the hypotenuse. It's always this long side of the triangle. So you'll notice I put 5 in place of c, and I didn't forget the square. Don't do that, that would be bad. And you can see one more step down, I have 5 squared, then turns into 25. On the other side, for the legs, I know that these are consecutive integers. So if you remember back in chapter 2, we said if you call the first consecutive integer x, the second one has to be x plus 1. Because consecutive integers would be things like 10 and 11, or 17 and 18, going up by 1 each time. Okay, earlier in this video we did consecutive odd integers and we went up by 2, which would be also true for consecutive even integers, but these are just regular consecutive integers. So we have our example. I plug in the x for a and x plus 1 for b, but now I have to square the x plus 1 because I can't have those parentheses. So if I do, this is all a right here. A is this x squared. B is x squared plus 1. You get x squared plus 2x plus 1 when you multiply that out. And now I have to clear my board and make some more space. So get that written down, and then we'll move on. All right, so now we're picking up where we left off. I did leave the problem, though. Here was our last line on the last board. X squared plus 2x plus 1 is equal to 25. So first thing I did, I combined my x squareds, giving me 2x squared. And I brought that 25 over. I subtracted it. 1 minus 25 gives me the negative 24 there. All right, because remember, we have to have 0. If you don't have 0, not going to work. I have a common factor, right? I'll write it down here, but we have a greatest common factor here of 2. So I divided all 3 pieces by 2 and set it down in front. I then factored the trinomial, x squared plus x minus 12. Again, it's a nice basic trinomial. It's going to be positive 4 and negative 3 that makes it work. Right? 4 times negative 3 is negative 12. 4 plus negative 3 is positive 1. And then I split it up. Here, I just ignored the 2 because remember we talked earlier how a number can't equal 0. So we don't have to worry about the 2. But x plus 4 could be 0, and if you subtract the 4, you get negative 4. And then x minus 3 could be 0, which would give us x is equal to 3. Now, again, this is a triangle, just like that rectangle example we just did. So the negative 4 is not really an option. We're going to throw it away. But 3 then is one leg of the triangle. There's one side. And the other one is one more than that, right? We had x plus 1 here, so it's 3 plus 1, and that gives us a positive 4. So there are my 2 legs. So they're 3 and 4. Very fun, very exciting. I enjoyed that. And yeah, good luck.